All right. My students are back.
There is a security seminar at the same time we have this lecture, and not a lot of people showed up, so there was a lot of leftover pizza.
Ah, where's that? I need to go there next time.
Yeah, it's a couple of classes.
Good. Don't tell our students.
Actually, I wanted to join, but the mobile class was so good.
I know, I cannot normally be there, but because my wife couldn't run it today, I had to run it. So, yeah, we had that situation.
Yeah. Okay. Right. So SQL. We're not talking about SQL in depth, but here's just an example of a select statement because it will tell you the intuition as to how the API looks like, how you're dealing with, and that's fairly similar for the insert and update statements here. So if you're familiar with SQL statements, you know that you're selecting basically the columns you want to display, right? Then you have conditions that constrain the number of tuples you get as response, and so on. So, and it's quite similar here as well. So you define what's referred to here as a projection. So if you have a getting a table, for example, and you have the identifier, you have column title and subtitle, whatever else, then this is basically what you want to get in return. So it would be the second statement following the select, and then you have a selection of what you actually want. The selection in this case would here the column title needs to equal something, right? So, and then we obviously need to bind this input value with some sort of actual value. So here referred to as the selection arguments, for example, my title. So give me all the ID, title, and subtitle for any of the entries that for which the column name title equals my title, and then you can indicate how you want to sort it, either ascending or descending, and you do that in associating with the column that you actually want to organize the output by. And then basically you inject this into a query on your database. So first you get reference to your database with the method I mentioned before, open or create DB of choice and so on. Then you say db.query, give it a table name and then all those parameters, and you get a cursor as a response. And the cursor is the kind of a pointer to record set that all the results you're actually getting, and yeah, then you can iterate through those and actually consume them and use them. Noteworthy here that by default the cursor points to -1, so you will need to move the cursor in the record set by 1 before you actually can consume data. That's done here. So while we can move to the next entry in the record set, extract some the content. So for cursor, get column or get column index or throw. So you basically give me the index of the column feedback entry ID. Again, this was defined in the projection before. And then add the items to some sort of list here. Again, here's a list that basically just consumes the item. So you have a list of item IDs that you can afterwards consume. That's basically how you interact with the database. Quite straightforward. I don't know. So magic, problems, concerns? Bit different to Java world, but since you don't have too much exposure, at least some of you, it won't confuse you. That's good. Yep.
Is the cursor like the views in SQL where you are shown a preview of the data but not the actual data?
No. Oh, sorry.
Yeah, so you can't like edit them, but you can review them?
No, think about it more like a pointer across a set of records as responses you get, not an extract, not a subset of the. A view is generally a subset of the data, right? So yeah, that you're dealing with. But here's the complete response that you get. You're just iterating through it using a cursor, basically like a pointer. Think about it. Yeah, one tuple by tuple. That's the idea. So as long as you can move it forward, because eventually this will return false here. So meaning if you can't move it anymore, then it means you actually ended up at the last entry of the record set. So and that's where the consumption stops. That's basically it. It's just their way of iterating over data. Cool. So yep. So looking at the cursor, that's probably more interesting aspects here. No? So there are some interesting methods to be mindful of. Column count or get the count. Here, column index. So if you have a column name, you want to get the index of the column, which you oftentimes need to get. That's your method to do. And moving within the record set is an option as well. Yeah, so basically that's SQL. Once you start playing with it, it should be quite straightforward, especially since you had databases on the course anyway. What Android has introduced recently, though, is a yeah, pretty much de facto ORM solution. Does anyone know what ORM stands for? It's actually quite surprisingly nice. Yeah, again. Yes, right. Object relational mapping. So what's the key idea there?
That you map an object to a table, a database, without using SQL.
Exactly, right? So you're automating this link of either extracting or serializing an object to a database without actually dealing with the SQL stuff. 20 years ago, I think, or 30 years ago, people thought SQL was such a nice abstraction from the underlying database. Nowadays, we move one level higher. SQL, really? Are we going that low level again? And here the idea is basically that you directly connect directly connected to the objects you're actually using. So it's born out of this 1990s fashion of object orientation. Everything needs to be an object, but we need to keep them, make them somehow persistent, and that's where object relational mapping came about. And there's a set of frameworks available for Android, usually written by third parties, but as of late, I think there was a need felt in the community to have a library on their own called Room. Has been introduced in July 2017. Did you play with it by any chance? Hello?
So ask it again.
Room. So my students paying attention. That's interesting. So it's called Room.
I'm watching YouTube.
You're watching YouTube, not mine, right? So you're a bit behind. Give him a moment. So let's see when he gets there. Right. So right. So the idea is here. I just want to briefly introduce it. It's very, very young. It's only became stable in July 2017. Quite straightforward, and it's literally what you said before. It's automating this mapping, so you don't need to deal with the SQLite database. It's so wonderfully convenient at this stage. So even a bit more involved here. So there are alternative solutions here. They're called Active Android Realm, ORM Lite, it's ORM Lite alternatives. But I'll just go into the Room Persistence Library because that seems to be, I think, something that will stay around. So it's worthwhile for you investing a bit time of it into it and having a look at it, but also developing experiences there. It's not part of the it's not part of the core environment yet. So the core API. So it's the dependency you actually need to load. In Gradle, so in Gradle you will need to add the two additional dependencies here for both the actual implementation of the runtime and the annotation processor for the Room framework. We'll get to that in a second, what that means. So the key idea here is that instead of using a database and your application or activity on the upper level or higher level, is that we have three components. So we have the database running in the background. We have a concept of entity, which roughly corresponds to a table. Well, you know, even in SQL and relational databases corresponds to that. And then what's referred to as a DAO, data access object. Yeah, they like objects, I guess, in this context. So that's your interface for basically dealing with the stored data, right? So those three components, and then ideally you just can directly operate on your data. So using your domain, specific class, let's say user class here, quite straightforward. In fact, I actually took it from the tutorial there. Is that you have, for example, unique identifier, further attributes such as name in this particular case. And what you do, you characterize the class as an entity using annotations. So in Java, if you do annotations, it's always at and then the annotation name. So it's kind of a bit of a meta-programming approach here that you can actually explore. Or using reflection in Java, if you want, you can actually explore all the entities in a Java class that have a particular annotation and do something as a response to that. So you're not necessarily executing the code, but inspecting the code before deciding on its execution. So referred to as reflection. And annotations is an important part of it. So that's also part of native Java. So it's not specific to Android, but this framework is. So you define or declare the entity, and you also need to declare the particular fields. So for example, columns. For example, named columns would be annotated using column info, and you're basically indicating the name that should be used in the database. So, because in the end you could still access the database and use it, but it's just translating the encoding here, and you need to indicate the primary key, which in this case is the tag primary key to do that. So it's just for simplicity there. Quite straightforward, right? So it's the only thing you need to do. Once you have your class, you kind of annotate it. And then you need to think about a DAO. And that's basically where things are somewhat mixed up. Think about the DAO as a, it's the interface that you use to access your users and store them and so on. And the idea is here, again, we're using annotation, so the whole system is annotation based, to indicate firstly what interface is the DAO, secondly, what's the queries that are attached to it. In this case, for example, for getting our users, we have a classical SQL query. For listing users with a given ID, you have this mapping here. So you basically have your skeleton SQL code, but you map it dynamically to the parameter name. Note it's case sensitive with respect to the name that you chose here, and that's the syntax to actually address it, so to bind it, to link it at runtime. Similarly here, so if we, for example, want to find someone by name, select everything from user where first name is like first name and last name like last name. Again, note here the parameter names are decisive in determining the syntax for the annotated query. And insert just takes a an arbitrary number of instances of the entity instances. So you can pass an arbitrary number of comma-separated instances of users there. So it's not constrained in terms of the number of users that you can pass along. And for deletion, similarly, it expects one single entity as input, and you call delete, and it will deal with you. It will deal with the resolution of the user and actual deletion in the database, and so on. So quite straightforward. Cool. So what I want to highlight is cool. And the last thing then is basically to think about the database. And here you actually need to implement or extend rather the room database, which provides you with the necessary building functionality. We'll get into that in a second. And it needs to have some sort of way of accessing the DAO. So you indicate the database, the contained entities, extend the room database, and provide access to the user DAO. And when you then ultimately build the database, this will be implemented up there. So DAO is the key there, that it actually bounds to the underlying database and then is accessible using the DAO object. So in this case here, you would create an instance of app database. Yes, that uses the app database class and for a given database name. So you could in theory also access the database using conventional ways from within an activity and then build it. So it would develop, write the implementation for that whole idea. Does it somewhat make sense? Yes?
So when do you build it? Is it during installation of the app? Or every time you open the app, or every time you open activity?
No, but you need to, you would call the build, but it would identify whether the database was built. It would keep the state consistent. So it would check whether the database exists and is built with room, and then give you access, so you get an instance or build it.
Okay, so you build it on the first time you start the app?
When you use it, right before you use it. It depends on how you see the performance issue. If it makes sense to build it in advance, and so you don't have that build effort once you press the first time save, right, in your activity. But in principle, before first use anyway, sometime. So, yeah.
Yeah, you have to have some sort of a helper class which will build it when it doesn't exist. Yeah.
So, anyway, that's one way to explore. It's actually quite nice. Did you play with this thing? Now, since you're caught up with the stream. Good. So, but it's probably worthwhile trying it out, I guess. Seems to be quite hot. And it's still under development, so I wouldn't necessarily expect it to work super robust-ish.
Exactly, it is relatively new.
So
I've been using the traditional SQL helper class for the SQLite interactivity. So I haven't used the modern mechanisms with annotations.
But those things have been around for Java for ages, like Hibernate and so on.
Yeah, in the core Java, that's the way
very old.
you do it. Yes.
So if you're coming from that world, then you won't be surprised by the functionality here at all. There's some indication which I found interesting, the way of annotating foreign keys, how you do it here. So you're actually referring to, for a foreign book, you're pointing to a foreign key using the entity and then the associated columns. So the that are actually point in the foreign entity that are pointing to the relevant columns. So there's more about joins, migration, exporting schemata if you need to, and so on, stuff like that, all in the documentation. So the link is here, but it's also at the end of the slide set, so you can explore it there. Again, worthwhile having a look at it. The final thing before we forget is, I think, the probably most important thing, content providers, I guess, because that's, as mentioned here before, is the most abstract way of dealing with data in Android. So this is basically the second component that we're actively dealing with. We have dealt with activities. We talked about all four, but we actually only have dealt with activities so far. Because you can for small and lightweight applications, but as soon as it gets a bit more involved in terms of data or event management or background activity, then you need to use the other three ones as well. But it's time to look at the content provider here. So, and the idea is basically that if you have two activities, Act 1 and activity 2, they that's my representation for data. Don't laugh. So each of the activities have their private data, right? By default, you're not supposed to share data via database or via the file system, hell forbid. I mean, you could do it via the external file system, you get away with this, but it's more clunky than necessary. But the question is, if this activity actually needs to consume data or actually requests data from another activity, and this one is meant to or intends to return it, and vice versa, this is the point in time where you actually want to think about possibly using either content resolvers most likely, but even better, if you want to separate out the actual data from the applications entirely and only make them accessible independently from the activities, that's the point in time where you actually want to use a content provider, such as, for example, your contacts, right? So that may be owned by a particular application, but in fact, they should be owned by most applications on the, or accessible to most applications on the entire phone, right? Because if you, for example, have the standard SMS tool installed, you have WhatsApp installed, Skype installed, and so on, they all use the same contacts basically and provide add some additional entries, increase complexity, but fundamentally they're using an underlying content provider that's associated with this and resolve it. And this is basically the idea that we're dealing with right now. So activities can shift around data, we get to that in a second, themselves, or actually use content providers for as a matter of abstraction. And yeah, so one of the key advantages for using this content provider is that it gives you, and it's always over abstraction, a uniform interface of accessing all your data, but it doesn't actually care what the underlying implementation is. Let's say you're responsible for the implementation if you're writing your own content provider, but the interface is uniform, so it's quite straightforward to actually access it, and you can easily migrate, for example, from a text-based representation to a database, perhaps to an online solution or whatever else, just by modifying the content provider as opposed to affecting the activity that actually uses it, right? So there's another form of separation that we're dealing with there. Fundamentally, it's the data, from an interface point of view, it feels just like interacting with the SQL database, frankly. So we have tabular data that we're dealing with. The invocation is even similar, so you find the method signatures are quite straightforward and very comparable. The only difference is there, the way, or most of the differences lie in the way we address it actually. So in order to make them accessible across the entire landscape of installed applications in the in the particular instance of your Android device or emulator, they need to have a unique identifier, and that's one of the key things here, that we actually need to define a schema that allows you to, or URI that allows you to address the particular content resolver. So in the components generally, it's fixed prefix content, so we know it's a content provider, then some sort of authority, which is referred to generally the namespace of your application that you're writing, and then a path within. So you could have possibly various content providers that belong to your particular application, but they have different purposes. One's for books, the other one for articles, third one, I don't know, for stuff, I don't know. Yeah. So you could structure the hierarchy a bit, but again, it's basically just a string that's used for resolving the particular content provider that you're using for your application. Cool. So as I mentioned before, the interface of the content provider is actually fairly fixed. It's quite straightforward, but it's a separate entity. Therefore, it also needs a separate entry in the Android manifest. Let's see how far we get here. Did I say a Java class? I just want to. So good luck to the stream people that may actually be interrupted here now. Other. And then we have a content provider. So you need to define the authority. So if you create a new content provider instance, so you can also do it simply manually by just using any class and extending it with context provider. It will force you to implement the following interfaces here. So you see it's fairly straightforward. We need to be able to delete entities. We need to be able to get the type for particular entities, because you may possibly, I don't know, send, pictures or whatever else, any sort of internet standardized format to it. Insert entities and so on. Have an onCreate method here. For example, whenever you create the content provider, do the following, like setting up something in the background, right? So that would be bring up the database, setting up an online account, or I don't know what's associated with this. You can come up with this. And then you have the query functionality here, and you'll find that this is, from the syntax point of view, fairly similar, or in fact pretty much nearly identical, apart from the UI obviously, to the one we use for SQLite as well. So we have an identifier for the content provider we're dealing with, the projection, meaning the table columns you're interested in, then the selection constraints, and then things like a sort order, if you want to have ascending, descending order, and so on, right? So those are the kind of things you implement, and that's pretty much all that's it to a content provider, but you are responsible for, building that functionality. From a specification point of view, there's no requirement to implement all those methods. You can also just simply return a unsupported operation exception, as it's written here by default. So it's fine, the system should be able to deal with this, right? So that's part of the idea as well. So if you don't have that functionality, don't worry about it. But that's what you would need to implement. So basically your pathway into yet another persistence mechanism as offered by Android. The main difference you see is actually in the manifest. If you look at the manifest, so here's our entire application. Here was our activity that I created earlier, is the main activity. But now you should also see here down here, there you go, a new entity called provider. So that's the one content provider. And what you see is basically a reference to the class name, the authority, and whether it says enabled and available for outside use. So that's yet another component that's basically available here. Yeah. So we won't have time for implementation anyway, but what I want to instead look at is how to use content providers, because that's something you do much more often. For this purpose, you use the counterpart, that is the content resolver. Basically, how do you actually get access to the underlying data that's in a content provider? Because there's a large number of them available in the system per se. Are we actually writing content providers?
In the labs, no.
But in the projects, right?
In the project you can use it,
Oh.
but it's not mandatory.
Oh. So it's kind of flexible because there's quite a breadth, as you hopefully have seen now, quite a breadth of different ways of storing data in Android. So you may not actually need to even use it. But getting back to the content resolver. So if you look at the top line, you get the content resolver that's available from the context of your activity. So you just say get context resolver, and then you invoke a query, and you need to identify, because that's literally the syntax of the query method, the signature that you just saw before. We query a content provider by its URI, basically. We need to know that URI. Oftentimes they're stored in constants that are associated with the content provider implementation. So I think it's best practice to have a content URI constant in your content provider implementation that can be used from other activities, right? So it can be referenced here. In this case, context contract with a or the context class within there has a field that's called content URI and actually pointing to the URI, as I mentioned before, this is given schema. And then you invoke it. So in this case, for example, we want, what would it do? It would give us everything from this particular content provider. It would give us all the display name for all entries of each contact that's in your system. So that's basically what it would return, because we don't constrain the selection. We're not saying we want to actually only have a context that starts with an H or whatever else, right? So cool. And then the pattern is again as similar as before. Again, cursor position defaults to -1, so you need to shift it by 1, and then iterate over the results and do something with it. You get the display name, so I don't know, you do stuff to it. Second example I want to show. Actually, I was running out of my machine, it was bogged down so much that I didn't dare to do it here. So the second one is the updating something. So, and here the idea is you need to get the URI for your content provider, and then you specify content values, and that's nothing but a key value, basically like a hash map representation internally that you need to set up, and then you set conditions. For example, you want to update all username and password with those particular values, where the ID equals some sort of selection argument. Here in this case, this one is a placeholder value. And again, you call get content resolver update and then the URI along with those selectors. So again, it's literally like assessing the SQLite database to some extent. The only main difference is that you use a unique identifier, system-wide unique identifier for your content provider. What I'm missing, I mean, given the number of the different content providers, what I'm missing is a registry that lists you all possible available content providers. And there are some informal community or crowdsourced ways of dealing with this, but or kind of collation of content provider URIs. But in the end, it boils down, you kind of need to know what's on your system-ish, and then to actually use them, right? Do you know of any registry? I remember we had open intents a few years back that would list all the possible intents on a.
Yeah, I don't know the latest on this.
But it would be good.
There will be something.
Yeah. So that's worthwhile looking at, because all the available content providers having a list that would give you actually good intuition. Because right now you're more or less forced to, okay, I want to use the context, or I want to use some other application. Does it firstly provide a content provider, and what's the URI? That's the only tricky bit you need to kind of figure out. Yep.
So, for example, if I want to store something in Google Drive, the Drive app, or would I use something like this then? Would I ask for the Google Drive content provider?
Yes, you would use.
Maybe that's a bad example, because you can go directly.
Yeah, exactly. So
that's what students typically do. Like we, suggest them. For example, if you have a backend with some sort of cloud storage or RESTful storage, to wrap it up as a content provider, but they end up having some sort of API which talks directly to the service, right? The advantage of doing a content provider is that you can mock the actual data, like with a file or local storage, right, for testing. If you're only interacting with the, your cloud API, you have to mock the backend, but it is better to do it this way, but it's a little bit extra work, right?
But you get also a few benefits out of the box. For example, you can hook it into the sync application of Google, of Android, so it actually syncs the data as well. That's going through your content provider if you want to. So you can easily plug in additional functionality like that.
Yeah.
You know, like the way you can sync your Google accounts and for all your application, the data and so on, out of the box, and you can do it with content providers as well. So you hook them in basically. So point is, those are all options. They are not the constraints of the system. So you can use any other conventional way you would think about, including like native Java library options, often to manage your data. But I think those are the recommended ways of dealing with it.
So unfortunately they don't provide any registry, but there are two standard ones. It's for contacts and for calendar entries. Yeah. Those are the built-in ones, which every app is using. I mean, every app which is using calendar or contacts. But there is nothing which is kind of a global registry of known providers, unfortunately. Yeah, you would have to dig out particular one.
Does OpenIntent still exist? .org?
I can check.
Because the simple, anyway, we get back to that, because then in principle you could just, whenever you submit the application, you could register UI, and anyone who's having your application on your system would be able to know how to access the data from UI, from your content provider immediately.
It does exist, it works.
Yeah, but it's very outdated, like.
They have no date.
Ah, yeah, okay. Anyway, there was a question there. No?
Okay, so how?
No, they've added a latest open intent that was added was November 2017. So
oh yeah, cool.
Still
so people use it.
Yeah, it's still being used.
Okay. I'll just bring it up, probably.
They had a big gap between 2009 and 2015.
Yeah, that's
so
right.
Before we've used it, and
yeah.
But it seems to be up again.
Then start. Is it like that? Still?
Yeah.
Cool.
So if you go on intents registry, you will see the up. Yeah. You will see all of them, and then if you go to history on the right side up.
Right.
Yeah, you see the updates.
Okay, so there's a bit of activity going on there. Cool. Yeah, but the idea here is similar for intents, that you can register specific intents that are associated with any possible app that you're dealing with. For example, for this particular application, the intent was basically provided here, so you know already how to interact with that application, even without looking at this, having access to that application in the first place. So, but you could set it up a requirement for your application to run if you want to use a third-party functionality. But we were wondering whether the same thing exists for content resolvers. Here's only for intents,
no,
basically, only for activities.
I don't think so. But
all right, cool. Yeah, that's the idea. Cool. Last thing I wanted to briefly talk about before you all fall asleep. Hint. Okay. All right. Okay. I'm still awake. Special case of content provider is FileProvider. So we also need to deal with files sometimes. In fact, one of the possible issues is if you want to pass a file between applications. That's the classical problem, and the file actually belongs to a particular activity, right? So, as we discussed before briefly, the idea is that internal storage keeps a hold on your files, and you're not supposed to share that anyway. But how can you share it possibly? And that's where FileProvider comes into play. But it turns out the FileProvider is largely a specialization of the content provider, and it's mostly by configuration. So it's not so much implementation, like in the content provider case, you actually need to write the implementation, the boilerplate code of dealing with storage. Here it's really about just configuring the system. Again, as before, you need to have you need to register your file provider somehow, including the ability to grant URI permissions. So it needs to be able to grant permissions on files, so applications can actually delegate access to files that are outside of their ownership, right? So this application can actually tell the second activity, you can actually use my file with a certain expiry, or until the system reboots generally. So, but we'll see how that goes. So first you register them in the manifest. The next thing is there needs to be an indication as to which folders should be made accessible in XML format, including and there are different ways of doing that. So you can indicate private folders, external folders. Here is the example of the root folder on the external drive. So the attribute here is external path or the external file path. That's very similar to the API calls we had earlier in the environment, where you actually look for your data path on the internal storage, your root for your application internal storage, and the same for the external storage. You can do that here as well. So the only difference is literally the attribute here, but you then need to indicate the name and the location within that within your application path of a particular file that you want to make available. So you need to specify the files. And yeah, so they are held in XML file, so you need to tell the system where it actually sits. And by default, it would be something like this. So in the REST directory, in the XML subfolder, you could have an XML file that has all the file paths in this format here, basically. And you just reference it again from the manifest. So you tell the provider that it has needs to manage the following files here. And then you basically need to just generate from within your activity, the one that is actually sharing, you're generating a URL for a given file. So you access the file directory, which is private to a particular activity, and you generate a URI for that particular file that you want to send over. And generally you would use the authority. That means the specified authority, so part of the URI of the file provider. So which would be derived from your context, the authority and the file name actually, and would grant the permissions. So you generally do that by calling grant URI permissions, and you just need to indicate, okay, for this file, give the following permissions. So other applications or activities can actually use it. That's the key idea here. Following two ones are available is the grant write and the grant read permission. Write implies read in Android, so so you can decide which one to use based on the extent of functionality you want to provide. So if then application, let's say application 2 requests a file from application number 1, application number 1 can basically create a content. Application number 1 we can basically send the file to application number 2 by using a notion of intents. So you're basically following an intent request. You would set a call the set data functionality on the intent to actually specify the URI. So the system then so it doesn't actually send the data directly, meaning not the file itself, but a reference to that file. And you also need to set the permission set along with this one. So basically intent set data and intent set flag. We'll deal with flags in the future again, but one of the flags you can set is then the permissions that are delegated to the activity who doesn't actually own the file you're referring to, right? So that's the key idea there. That's all there is to the file provider activity so far. Anything else needs to be mentioned? So this is basically, so most of it is done in manifest, so specifying the file provider, specifying the folder. This is done in an XML file. Both of it is tied up again in the manifest description. And then from the activity, you need to derive the URI and then pass it on to intents. And this will basically delegate the whole file handling plus the permissions problems to the operating system, because based on the intents and the URI, the system knows, okay, where's the file, number 1, number 2, what are the permissions on the file by a non-owning activity, right? And those permissions last until your system is rebooted generally, unless you revoke them with an explicit call to them. Anyway, that's that. Cool. So yeah, so we roughly made it. It's quite a bit of dense content spread over those 2 hours for all the different ways of dealing with data, but I put the slides up, so and most of them have code, so you can actually directly hopefully use it. And those are the ones we talked about. So configurations, use shared preferences, private files. If you don't want to deal with permissions, use internal storage, plus it's always available. External storage a bit trickier, you need to check for availability. SQL, we talked about this. And then it's the strongest level of abstraction would be simply the content providers, as we talked about as well. But again, once you understand SQL, you understand content providers as well. So the resources are all listed on the last slide. So if you want to look up some of the aspects, they're basically all pointing to the default documentation by Android, which is actually fairly good, I think, for a for the whole Android API, but particularly for storage. So you can have a go at it. Cool. Cheers. Thank you. Any questions in case of the remaining survivors? If not, happy weekend.